Okay, you ready for a challenge? Today we're going to do a base pointer exploration. So grab the worksheet, and then I would advise that before we get started, I linked two articles to at the top of the worksheet. I would strongly suggest that you read through those before we get going, because that's what we're going to be learning, and have a little pre-knowledge about what we're going to be finding would be very helpful. But if you want to try this first and then go back and read it, that'd be fine. So I will follow through with the getting started, and follow along, and good luck. This is going to be a challenge, and it gets a little messy a little later. So following along with the getting started. So last time we did the echo set dis Intel, set disassembly to Intel. Depending on how you closed your VirtualBox, you may have lost that setting. When you close your VirtualBox in the future, go and when you do close here, save the machine state. If you power off the machine, you'll lose what you did. So in any case, let's go ahead and set up, just in case you lost it from last time. So echo set dis Intel, and we're going to put that into our GDB init file. So we're creating a GDB init file and putting that content into it. And we could always look at it. You don't have to do this cat, but this is just to look at the contents of a file. And I'll echo it to the screen. Next thing is, let's create a directory. So let's call it make directory stack. So now we have a stack directory for what we're going to be working on. And then cd stack to move into it. I posted a C file onto an FTP server, stands for File Transfer Protocol. One of the older, it's actually a peer of HTTP, slightly different protocol. So let's connect to the server. So it's signup.bergen.org. Okay, so I'm trying to connect to the signup.bergen.org via FTP, and it's not working from home. So it does work from school. So I'm going to connect in a different way. I'm going to connect to my own machine just to demo the process. So I don't use this address when you try it, but 192.168.56.1 is my Windows machine. And then you're going to type in the user. In your case, you're going to type in security@signup.bergen.org. In my case, it's shared. Then you're going to type in that password that you see in the worksheet. And at this point, you should be logged in. Now, continuing FTP, I'm going to type passive. And then I'll do ls to just list the directory. And we should see funcstack.c. So I'm going to type get funcstack.c. So with FTP, there's really kind of two primary actions. Get, which retrieves from the remote server to your machine. And put, which moves from your machine over to the foreign server. So I'm going to get this guy. And we should see that transfer is okay, and then you can exit and you'll be out of FTP. If you do ls-l or just ls, you'll see that you have a file there now. Go ahead and compile that file. So gcc-g-o func_stack func_stack.c. gcc-g, apologize. So it's compiled. Let's run it. This might be actually useful to recall later. You're going to want to steal some of these values, so you don't need to calculate them as we're working. But you can always scroll back up to look at this output. And then let's launch GDB. So it's GDB-Q and then the program name. And we are inside GDB at this point. Turning to page 2, you will see the program that we're dealing with. So you read through the C program and then continue reading, and you will see the disassembled versions of the code. So you'll see func A, func B, and then main. So take a few minutes to read through the program. Try to relate them to each other. I bolded a number of the registers, and that's what we're going to be talking about a lot. So you can pause me as you read through the program, and then we'll resume on page 4 with question 1. Okay, so I will presume that you read through everything. Continuing on 4, so it says review main in the C program, then review main 16 to main 32. So let's go take a look at those. So I'll talk you through this for now. These are answers that I would like you to be able to figure out on your own as you get better at this. But let's just talk through it. So main 16, I see a move D-word pointer. And actually, let's bring it up. So we're looking at these steps right here. And take a moment to think about those. Go back to the C program and see how those relate. So I see a 2 being moved somewhere, a 5 being moved somewhere, and an E, which corresponds to 14, being moved somewhere. And then a call to function B. All right, so go look at the C program. So, a 2, a 5, and a 14 preceding a call to function B. So there's something going on there, and we can notice the order that they're being added in. So think about that and see if you can write down an answer, and we'll continue in a moment. So I'll presume that you wrote down your answer if you're continuing. So after those 3 lines execute, we see that we make a function call to function B. And then after the function call, we're moving EAX to a place in memory. So what could we be moving after a call to a function? So go take a look at C again, the C version. So we'll notice function B up here does the execution, but it returns a value. So what do you think EAX represents, or what does EAX hold? So that would be your answer to number 2. Finally, go ahead and read through the lines 50 and 54, the assembly main plus 50 and 54, and try to determine what's happening here. And you've seen this pattern before a little earlier up. So go ahead and answer those. Okay, next, let's look at number 4. And for number 4, we want to complete this table. Wherever there's X's, we're not going to worry about those. And so what we're trying to show is there's a EBP, and then some relative addresses, and then some unknown number of addresses that occurs in the middle here. And then we have the stack pointer, and then some values, offsets moving from there. And so we've seen all those as we've been working. So let's see what we can figure out. So let's look at the ESPs first. So again, that's the stack pointer. So we have the stack pointer plus 4, and the stack pointer plus 8. So go back to your assembly program, and let's look at the main 16, main plus 16, main plus 24, and see if we can make heads or tails of that. So go take a look at those and see if you can describe the purpose of those memory locations and what they do. They're actually used in 2 different places in this program. So up at 16, 14, 32, those lines, and then they're used again down in 50 and 54. So the values do vary, but they have a common purpose. So answer that. And then likewise, the EBP minus 4, that has a purpose. So you're going to look at the C program again. We've talked about this before. Figure out what the value is, and what does that represent, looking at the C program. So let's see if you can answer those. Okay, let's assume that you finished the table, and let's go below the table, and we'll do a little bit of GDB work. So we're going to add a breakpoint in main, so we can start doing a little bit of debugging. So if you recall, you're going to put break main, and then do run, and it'll execute the program until you get there. Now we want to just check where we are in the assembly program. So again, we want to do examine X, interpret as instruction, so /I, and give it an address that we want to look at. So we're going to look at the instruction pointer. And we'll see that it's showing main 16. If we recall, prior to main 16, that's called the function prologue, where it's setting up the stack and so forth. So this is really kind of where the function begins. And now we want to look at what is the value of the memory referenced by the base pointer. So again, how we look at memories, we're going to do X, and then we do /X to say we want to look at it in hex, so we can put a 1X in there. And we're going to say go to the memory referenced by the base pointer. So this is very similar to what we just did with the instruction pointer, but instead of interpreting it as instruction, we'll interpret it as hex. So you're seeing two things here. On the left side, you're seeing an address, the FFF7F8. That is the value stored in the base pointer. But then on the right side, that's the value stored at that address. And so we're asking for the one on the right. We want to know what's what's referenced by the base pointer. So the FFF858. So next thing is we want to see what's in, what is the value of the base pointer register specifically, and what's the value of the stack pointer register specifically. So we could do it two different ways, but let's do info registers. That's going to list all the registers on the machine. And so we will see the stack pointer ends with a 7EO, and the base pointer ends with the 7F8. So note those down. And those should be the same on your machines. If they're not, please let me know. Continuing on to the next page. So now we want to add a breakpoint for our function FB. So go ahead and add that in. And let's continue to that. And again, let's do our inspection. So again, you can use the up arrow. And we'll see that we are indeed on the correct line. Do the same inspections that we just did. So again, you're going to look at the value. You inspect the EBP, the values referenced by the EBP register. Note that down. And then look at your answers to number 5 above. And then similarly, obtain the values of the two registers, the EBP and the ESP again, and note those down. I'll pause while you do that, and then we will continue with number 9. So number 9 says, using GDB, what is the value of where the base pointer is referencing +4? So x/x EBP/4. Okay, that's interesting. So it's 08048436. Go take a look at the main function, see if you can find that number 8048436. You should. At this point, I'm going to leave you. The questions are somewhat repetitive, but they will get a little bit more confusing as there are more addresses that we're dealing with here. So you're going to be looking at the offsets of 6 and 9 in question 10 and determining what those do. And then you have a larger table to try to fill out. And then you're going to repeat the same for function A, and then there's a debriefing page at the bottom. So good luck. Get some help from each other, and we'll continue next time.